Okay, so welcome. So now in this video, we're going to have to do some extra stuff. So and sometimes you've got multiplication and subtraction, addition all in the same thing. And sometimes you're going to have to use the distributive property to kind of break things apart to isolate the variable. So for example, let's say we have this accumulation formula for accumulation of a compound, right? What I mean by for an investment, right? So this would be like a compound interest type of formula, okay? So this is this is the simple interest formula, in a manner of speaking. But what we're doing is this is the accumulation formula. So this would be like the total amount that you would have if you invested a one-time deposit and the interest was compounded by simple interest. Okay, so again, I'm not going to get into all that, and it's unnecessary. But here, this is the formula, right? So if I gave you this formula, context included or not, it doesn't matter. And I said, okay, I want you to solve this for n. Well, n is inside the parentheses here, so I can't do anything with the n. I can't isolate the n because it's part of this product, right? Do you see that? Because it's a multiplication here. This times p. And so I can't do anything with it. The only thing I can do is divide both sides by this whole thing or this whole thing, and that doesn't necessarily help us, okay? But there are two ways you could approach this, okay? So either way is fine, okay? So again, I know the book shows you one way, and maybe a teacher or professor will show you one way. I'm going to show you both ways because in my opinion, you're using the same techniques. And it's two sides of the same coin. Okay, so one way to do it is, well, I can use the distributive property. So let's do that. Let's use the distributive property and see what happens. So we're going to distribute the p, so we get a equals p, right? 1 times p is p, plus p times n times I. Okay, right? Now, let's start isolating. Well, I've got this p, so let's subtract the p from both sides. And so now I get a minus p is equal to p n times I. Okay. Now I can use the commutative property here. Again, you could do this mentally too. You don't have to write this. But again, I just want to show you so you can visualize something. So I can write this as n times p I, right? Just to show you what to do, okay? So then I'm going to divide both sides because I want to isolate n, and this is multiplication, so the opposite of multiplication is division, so to undo this, to move the pi over here, I'm going to divide. So pi on both sides. So now pi divided by pi is just 1, right? So 1 times n is n. And so I get a minus p over pi equals n, which gives us n is equal to a minus p over pi. Okay, and I'm done. Now that's one way to do it. Okay, so here's the other way to do it. Let's say I don't want to distribute. Well, here's what I can do. Let's take the same formula. A equals p 1 plus n times I. Okay? Okay? So now I want to isolate this n. Well, I've got a product here. Let's just divide both sides by p. Let's move the p first. There's nothing that says that we can't do that, right? So let's divide both sides by p, right? So p divided by p is 1. So then I get a minus p, or a divided by p is equal to 1 plus n times I. Okay. So now I subtract 1 from both sides, right? So I'm adding 1, so let's subtract 1. Subtract 1 from both sides. So I get a divided by p minus 1 equals n times I. So now, I'm just going to divide both sides by I. And so I get A over P minus 1 divided by I equals N. Now, they do look different. Okay? Well, what happens here? Well, on the top here, this is a complex fraction, so let's simplify this. So let's get this to have a common denominator. So I can get this to be a common denominator by replacing the 1 with p over p, right? Because p divided by p is 1, right? So then I get a common denominator. And what can I do with that? I can combine the top, right, and keep the bottom. So what happens? I end up with getting A minus P over P divided by I is equal to N. Okay, so actually let's interchange this. Okay, so since we got the N isolated, I could have just interchanged it down here, but let's interchange it up here. Okay, now I've got this fraction divided by I. Well, this is the same as I over 1, right? So I can change this to a multiplication, right? By taking the multiplication of the reciprocal of the bottom. So I'm going to write this as n is equal to what? A minus p over p times 1 over I. And then now I just multiply across the top and the bottom, and so I get n equals A minus P over Pi. So I do get the same thing. This is the same as this. Now, in my personal opinion, I definitely would do the distribution, because you get a much simpler expression on the right than you do here. Okay? Or here. Okay? So again, the book shows you using the distributive property, which I think is the more efficient way of doing it, because you end up getting a nicer formula. Okay? But again, as you can see over here, doing it this way, you can get to the same answer. Okay? It does take some more steps. Okay? So just keep that in mind. All right, take care. I'll see you next time.